Hi everyone, welcome back. It's interesting once people get the hang of arithmetic progressions and geometric progressions, then we get the problem solving and that mucks a lot of people up. This is probably the most common question I've seen used over the years when someone drops a ball. And now it doesn't say to you it's an AP or a GP, it just gives you the information. Let's have a look at the information. If a ball is dropped from 120 metres and each time it bounces up to 1/4 of its previous height. By the way, in Australia we have a group of boys who are very famous who have a group called How Ridiculous. If you look them up on YouTube, I was watching a recent one probably about a week ago where they were using a helicopter with a huge ball of elastic bands which they put together themselves, and they were dropping it from heights and then measuring how far up it went. It was quite fascinating. Interesting part being rubber bands, as it got higher, the ball itself would start to pull apart. So, bit of fun, how ridiculous. Now let's have a look. So each time, let's write it mathematically. We started with 120. It drops down to 120. A lot of people will draw a picture and they'll go, put a scale on it and they'll say, it dropped down to 120 metres. Now it might have gone that way, but we're just talking about how much it went vertically. And then it went up to 1/4 of that. So we're talking about 1/4 of 120. Most people are okay and they look at that and go 30. If it was horrible numbers, you'd have to go 1/4 times 120 and 1. I could talk about multiply the tops and multiply the bottoms, but hopefully you're okay with working that out. So if it's going to go back up, 1/4 of 120 is 30. So if that was 120, it's going to go back up to here and then back down again. So don't forget that what we've got is we've got a 30 plus another 30, and students mix it up big time. And then it'll go up to 1/4 of a 30, so we're talking about 1/4 of 30. Now, my trick for quarters, well, everyone's trick for quarters is what's half of 30? Most people go 15. So you could talk about money again, $15. And then if you halved it again, you got the quarters. So half of that is 7.5. So next one's 7.5 plus 7.5. Now, the interesting part is this can be in the non-calculator section. So in Western Australia, 1/3 of the Year 12 exams are non-calc, and 2/3 are calculator allowed. And we have the fantastic, incredible ClassPad calculator available, as well as using a scientific. So here's our problem, what we've got here. Now, if I taught this a number of times, walked back in and taught this same video tomorrow, I might change my mind on how I teach it. I'm going to look at it this way. We've got 120, plus we've got these numbers. Now, I'm going to add the two 30s together. There's so many ways of doing this. So that's a 60. And then the two 7.5, we're back to 15. And it doesn't matter what the rest of the numbers are. Now, this one is a separate number. It fits in if we went 120, 30, 7.5. So if we went 120, 30, and 7.5, we'd be missing these other numbers. So you could do two questions in one. Two questions and separate into two parts. I'm going to do it as one question. And I'm going to go, I could call it the sum to infinity. So a lot of you would know what sum to infinity means. You just count it. By the way, it's so idealistic, but in the end, it's not bouncing much, and it basically just stops because of friction and other forces. But it's theoretical. Let's have a look what it is. So it's 120 plus this question here. And I'm going to talk about the sum to infinity. Most of you should know the formula. It's the first number on 1 minus r. So sum to infinity for this lot, but not for this number here. So we've got 120. I really think maybe every time I teach this in future that I would come back and just put a separate number and look at these and double them. So the first number in this case is this number here. Not the 120, we've already counted that. That's 60 on 1 minus 1/4. Let's have a look at the calculation, especially if it's a non-calculator section. And you've got 60 on 3/4 now. Here's where a lot of people come unstuck. That's why I picked this one and I made it 1/4 and not a half. If it was a half, the numbers are really easy. But most of the time in assessments, people don't use a half. Let's have a look. So we've got, I'm going to go up to here. I've got 120 plus 60. And I'm going to talk about invert and multiply. This is a divide. So it's a fraction of 60, or 60 over 1 if you wanted it, divided by 3/4. We talk about invert and multiply. I've heard in other countries they say it differently. So instead of going 3/4, you go 4 on 3. So you turn the bottom upside down and multiply. That's not too bad, but also a bit yucky. A lot of people have trouble with it. 120 plus. Personally, I'd go, there's a numerator, there's a denominator. 3 into 60 goes 20, because that makes life a lot easier. 3 into 3 is 1, 3 into 20, 60 is 20. So you've got 120 plus 80, and it works out a really nice number that travels up 200 metres vertically. Be interesting to actually get a ball that would do that. So even the idea that it's going to come up a quarter and come up a quarter again, what's affecting it? Wind friction, all sorts of effects when it hits the ground. I haven't really gone into the physics of it, but it's a very theoretical, what I would refer to as a pure mathematical look at it. It would be the absolute maximum at which that ball would travel. You'd probably find it travels a reasonable amount less, because at the end it's not going to go all those little bounces. It's like skipping rocks across a lake, and you can see it jump big and then jump less and then jump less, and finally just goes boop and it goes into the water. Oh, I'm having fun with it. I hope it helps. This is my never-ending list. I could put up so many. I don't know how many people are going to watch how many videos on APs and GPs. If you're enjoying it, please press like. It really helps. And thanks for watching. See you in the future.